something called Doppler shift. So this Doppler shift basically means that if something is moving towards you, it will be blue shifted. If something is moving away from you, it's going to be red shifted. And we're going to come to this blue shift, red shift very often because the entire universe is red shifting from us. That's the expansion of the universe. And so what I have here is a flashlight. This flashlight is yellow. So yellow waves are coming out of this flashlight. This observer sees a yellow flashlight. Then we're going to put this flashlight on an Ariane rocket. It's a French rocket. By the way, this rocket is going to take the next telescope, space telescope, out to space. We're putting the American space telescope on a French rocket. All right, it's called Ariane. This one is coming towards the observer at high speed, and then we put the same flashlight on a rocket moving away from the observer. All right. Here, because the flashlight is moving towards the observer notices that the waves appear to be compressed. So they appear to be shorter wavelengths. When you look at shorter wavelengths and it's yellow, it's going to shift towards the blue end of the spectrum. That movement towards the blue end of the spectrum, the shorter wavelengths, is called a blue shift. And the opposite happens when the rocket is moving away from us. When the rocket is moving away, it's almost like you're stretching out the waves. And so when you're stretching out the waves, what you see is that it's getting longer waves. So the waves are going to get longer. The distance between the peak to peak of a wave gets longer. Longer than yellow is red. So it's not necessarily going to appear to be a red color. It's going to shift towards the red end of the spectrum. So maybe yellow becomes orange. Maybe it's going to become dark yellow. It's going to be a longer wavelength. All right, so when we see something that is red shifted, we know it's moving away from us. When something is blue shifted, we know it's coming towards us. Now, this is sound, you can't see this. Now, how do we notice this? Well, we look at the spectrum. So we put the light of a star or light of a galaxy through basically through a prism so we can see the spectra. So we spread out the spectra and we can see that when something is coming towards us, these dark lines are the absorption lines in the spectra of the object. These dark lines are moving towards the red when the object is moving away from us. So the dark lines move towards the red end of the spectrum. And then when something is coming towards us, these dark lines move towards the blue end of the spectrum. And we can measure how fast they're moving towards the blue end of the spectrum. How much they're shifting will give us the speed at which the object is moving away from us or moving towards us. And when we look at things that are close by, we see that the universe is expanding, and not inside our galaxy. Our galaxy is gravitationally together. Like in the solar system, nothing is moving away from us, but the universe is expanding. That means the space is getting bigger. So when we look at the farthest things in the universe, they're moving away from us. They're redshifting close to the speed of light. That's how fast they're moving away. Now, I'd like to show you guys something. This is called, let me see if I can find it first. Okay, here we go. Oh, this is the correct one. So this is the same thing that I just showed you, except in sound. All right. So when the airplane was coming towards that soldier, that's a blue shift. Now, what's a blue shift in sound? That means the sound waves are getting shorter. That's a that sound. When it's getting farther, it'd be that sound, right? So let's see it again. Airplane is coming closer. And then it moves away. So now, how does sound differ from light? Well, sound waves travel like an accordion, like this. like that. So when I speak, I am compressing the sound. And then when it hits your ear, this compressed sound in your ear, some of them a little less compressed, some are more compressed. There's a little hammer in your ear. That hammer goes up and down, and you can hear me. That's how we speak to each other. That's how we make sound. Now, this happens on a molecular level, right? Really, really tiny levels. So there's little tiny, tiny compressions in the air that travel all the way from me to you as you listen to me. So that's how sound travels, not like light. Light goes straight, sound goes like an accordion, like that.